Hi, welcome to part 3 of electromagnetic induction. In this part, we are going to talk about induced EMF. Induced EMF. We all know that EMF is induced when there is change in flux. This is known as Faraday's law, and in this part, we are going to talk about Faraday's law. Okay, we all know that when there is current in a circuit that leads to magnetic field, this magnetic field because of this magnetic field you have flux, and when there is change in flux, you have induced EMF, and this induced EMF gives rise to induced current. So we learn that when there is change in flux, there is induced EMF, and this gives rise to induced current. Now what is flux? Flux can be written as B dot A, that is BA cos theta. So they can be d phi dt either due to change in magnetic field or change in area or change in theta dt. So change in flux can be brought about either by dB dt or dA dt or d theta dt. So now we are talking about change in flux due to dB dt. We can write that since phi is equal to B dot A or BA cos theta, d phi dt can also be written as A cos theta dB dt when d phi dt is due to dB dt. B can be found out either by using Biot-Savart's law or by using Ampere's circuital law. So when we talk about d phi dt due to dB dt, we can write d phi dt as A cos theta dB dt. And this B can be found out either by using Biot-Savart's law or Ampere's circuital law if the current is given. So any change in current from I1 to I2 will change B from B1 to B2. So phi 1 can be written as A cos theta B1. Phi 2 can be written as A cos theta B2. Phi 2 minus phi 1 by the time it takes to change is equal to d phi dt is equal to induced EMF. Now phi is equal to BA cos theta. We have spoken about d phi dt due to dB dt. Now let's talk about d phi dt due to dA dt, that is change in area. In that case, we can write d phi dt is equal to b cos theta dA dt. Now this A is the area vector, A can be, if it is a regular rectangle, let's see what happens if it's a regular rectangle, if the area that is enclosing the flux is a regular rectangle and one of the arm is a movable arm, like you can move this arm of the rectangle. Say you move it in this direction with a constant velocity v, and this is the magnetic field in which this rectangular loop is placed, and this arm of the rectangular loop it can be moved, and it's moved with a constant velocity v meter per second. Now every second, since it's moved with a constant velocity, so in 1 second what happens, this area of the loop increases by, this was the original area, this area increases by this much in 1 second. In the next 1 second, again this area increases by another v in next 1 second, and again in the third second, again the area increases by v, and this is the original area. This was the original area. So every 1 second the increase in area is v into, this was the breadth and this is the length. This was the breadth and length. So original area is L into B. L into B. Then every 1 second the length changes. L changes but B remains constant. So dA dt is due to change in length, that is dL dt is the cause for dA dt. So phi, which can be written as BA cos theta, d phi dt can be written as B cos theta dA dt. Since B remains constant, this can also be written as B cos theta. B is taken out and this is due to dL dt. So the whole thing can be written as B cos theta, and dL dt is nothing but velocity. Rate of change of length is equal to v. Every 1 second the change in length is equal to v. So d phi dt can also be written as B cos theta into B if the change is in the direction of, is in the length. Similarly, we have a magnetic field, and if the rectangular coil is placed in the magnetic field and let's make it look more like a rectangle. This is the magnetic field and this is the rectangular loop, and this time this arm moves. this arm of the rectangle can moves. This arm of the rectangle moves by, and the velocity is v meter per second. V meter per second. So this is breadth and this is length. So every 1 second the breadth increases by v. In the next 1 second again the breadth increases by v. So in this case the length remains constant. But b changes. So phi being equal to ba cos theta, d phi dt is equal to b cos theta dA dt, which is equal to b cos theta. Since L remains constant, we can put the L out and write dB dt. Since dB dt, the rate of change of breadth is equal to the velocity, we can write d phi dt as BL cos theta into V. And this is equal to the induced EMF. So we have spoken about d phi dt due to dB dt, due to dA dt. Now we'll talk about d phi dt due to d theta dt. Theta is the angle between B and A. A is the area vector. So if there is a magnetic field and we have a coil placed in the magnetic field which is made to rotate along this axis, then the angle theta between B and A keeps changing. It keeps changing as the coil rotates. The angle theta between B and A keeps changing. The direction of A is always perpendicular to the plane of the coil. The direction of A is always perpendicular to the plane of the coil. So if this is a coil of say n turns, then phi is equal to n b a cos theta. D phi dt can be written as n b a d dt cos theta. If this coil rotates at a constant angular velocity of omega, so we can write the same thing as NBA d dt cos omega t, which can be written as NBA, omega comes out, and sin omega t. Okay, there is a minus sign here, but this minus gets cancelled because d phi dt is actually minus of this. So this minus becomes plus here. The minus sign says that the induced current opposes the d phi dt, the very cause of induced EMF. So induced EMF can be written as NBA omega sin omega t. Now, since there is no space, I am deleting the ones at the top so that I can give more details about this induced EMF. So this is what we know about induced EMF. Induced EMF is written as NBA. I am just repeating this what we wrote over here. NBA omega sine omega t. So this part can be written as induced EMF is equal to E0 sine omega t, where E becomes equal to E0 when sine omega t is equal to 1. So this is the maximum value of induced EMF. The maximum value of induced EMF is equal to E0. E0. Now, what is current? Induced current will be E0 by R if R happens to be the resistance of the coil. So I0 is the maximum current which is given by E0 by R. So what is the power generated? Power could be written as E into I. What is E? E0 sine omega t. I can be written as I0 sine omega t. Okay, let me delete this part so that I can write more about what is power. So we have seen that power is equal to E0 sine omega t, I0 sine omega t. Same thing can be written as E0 I0 sine square omega t. So we multiply and divide by 2 so that the same thing can be written as E0 I0 by 2 1 minus cos 2 omega t. So average power can be written as E0 I0 by 2 and integrating it over a time period 0 to t and divide it by t 1 minus cos 2 omega t dt. So the second term becomes, this term on integration becomes equal to 0 and we get a t over here which cancels out with the denominator, t in the denominator, and we are left with E0 I0 by 2. So I just repeat, we got the induced EMF as NBA omega sine omega t. So induced EMF can be written as, this entire thing can be written as E0 sine omega t. E becomes equal to E0 when sine omega t is equal to 1. So E0 is the maximum value of induced EMF. Hence, the maximum current can be written as E0 by R if R is the resistance of the circuit. Power is given by E into I, which is nothing but E0 sine omega t and I0 sine omega t. So power can also be written as E0 I0 sine square omega t. E0 I0 sine square omega t. We have divided the numerator and denominator with a 2. So we get E0 I0 by 2 and 2 sine square omega t is also equal to 1 minus cos 2 omega t. So once we integrate the thing over a period of this formula over a period of time period t, the same thing can be written as E0 I0 by 2t 0 to t limit 1 minus cos 2 omega t dt. On integration, this part becomes equal to 0 and this part becomes equal to t minus 0. So this t and the t in the numerator and denominator gets cancelled and you are left with power average equal to E0 I0 by 2. So in this part we have learned that induced EMF is caused due to change in flux, and the change in flux can be brought about by change in magnetic field, change in area, or change in theta, theta being the angle between B and A. I hope you have understood more about induced EMF. In case of any clarifications, you can log on to www.olympiadtester.com. Thank you.